2 men, 2 philosophies, 2 choices, 1 decision. You decide.
Okay, good evening, everyone. I had the great pleasure of appearing here last year in a similar format, although last year's format was where the questions were already decided. This time it's more of an open forum. So we don't really have anything worked out. I thought I would just start off by talking a little bit about evolution, what evolutionary theory is. I brought with me some overheads, and you may hear Dr. Hovind, for example, be referred to as a creationist. We also talk about creation science, which is an attempt to prove creation using scientific method, those sorts of things. What I've brought here is sort of a comparison of the two models. Scientific creation model, which says that the universe, the earth, and life on the earth were created by supernatural processes. The universe and all its contents were created simultaneously about 10,000 years ago. Biological change since the creation has occurred within created kinds of plants and animals. And the fossil and geologic records are the result of a worldwide catastrophe of a hydraulic nature, specifically the biblical flood. The evolution model, on the other hand, states that the universe, the earth, and life on the earth evolved by testable, natural processes. See if I can get that centered. Number 2, the universe and all its contents evolved over time. The universe is about 15 billion years old, the earth 4.5 billion, and life on earth about 4 billion. Changes occurred within species, and new species evolve from existing species. And number 4, the fossil and geological records are the evidence for billions of years of systematic change. Well, let's talk about evolution. And let me see, it's kind of hard for me to see, it's dark here, but how many of you really know what evolution means? The definition of evolution. If you're absolutely positive, you know what it means. Let me give you my definition of evolution, and one which a lot of biologists, anthropologists, chemists, physicists, all sorts of people of a scientific nature, how they use the term. But I'll just give you my definition. This is the definition I give my students in class when we sit down. Evolution is specifically a change in the gene pool in a population over time. It's that simple. It's a genetic change over time. Now, let me ask you a question. How many of you in this room tonight are exact carbon copies of your parents? Anyone? Raise your hand if you're an exact carbon copy of your parents. Do you know why not? It's because from one generation to the next, and if I use this room as our population, a population is a group of organisms. Okay? If I use this audience as our population, we could perform a little test for evolution. And we could see whether or not the genes, right, your genetic makeup, what makes you you, are the same from one generation to the next. And if they're not, according to my definition of evolution, a change in gene frequencies in a population over time, that is from one generation to the next, if the genes have changed from one generation to the next, my definition of evolution is correct. If you're not a carbon copy of your parents, that means you have different genes. In fact, everybody in this audience is a combination of the genes of their parents. All right? Your mothers and fathers got together and bore a child, either male or female, and that child has half of the genes from his or her mother and half of the genes from his or her father. It's that simple. We're combinations of our parents. Siblings work out the same way, with the exception of identical twins. Even siblings aren't exact copies of each other. You know, brothers and sisters don't turn out to be exactly the same. Well, we talk about this in terms of microevolution. And, you know, I've heard Mr. Hovind say before that, you know, microevolution, I don't think he really has a problem with that, because after all, they're going to talk about changes within kinds of animals. Noah took on the ark 2 of each kind of animal. 2 dog kind, 2 cat kind, 2 ungulate kind, those sorts of creatures. Well, they have to explain, if Noah took 2 of each kind on the ark, how then do we get the diversity of species that we see today? Why do we have so many different kinds of dogs? Why do we have Dobermans and Dachshunds? And I've got a Chow at home, right? Different kinds of dogs. Well, that's microevolution. It's what we consider to be a change within a species. In fact, one of the other things that I teach my students is that we can see human evolution sort of in process. Let me ask you another question. How many people in here were born or have all 32 of their human teeth? Anybody still have all 32 teeth, including all of your wisdom teeth? You younger folks probably don't have your wisdom teeth yet. You're only going to have 28 teeth, okay? As long as you have your adult teeth. Anybody in here had to have their wisdom teeth removed? Taken out? Come on, raise your hands. Don't be shy. We can put our hands up. I had my wisdom teeth out. Why do humans have problems with third molars, wisdom teeth? Why do we have to have them removed? And what happens to you if you have problems with them and you don't have them taken out? What happens if they get impacted, infected, if they grow in crooked? You can get very sick from it. You can die from it. Well, that seems like an imperfect design. We put a design flaw in the system. We're going to make an organism that has too many teeth for its mouth. In fact, it has so many teeth for its mouth that it's going to have problems with them. And if you don't have access to modern medicine, fortunately we do, we can go to the dentist, and the dentist can put braces on our teeth, or the dentist can pull some teeth. Right, I had to go to an oral surgeon. It was really nasty. They had to go in there and cut my jaw open and take out my teeth. And in fact, they severed my mandibular nerve while they did it, so I have a dead spot in my lower jaw from it. When we look at human evolution, and one of the things that I will encourage you to do tonight, I brought along some fossil casts of some of what I consider to be our human ancestors. Okay? And I'm going to lay them out on this table, and I encourage you all to come up and look at them. I'll ask that you be careful with them because they're kind of expensive, and I don't want them to get broken, but feel free to come up and look at them. In fact, I'll be pointing out some features tonight on some of these casts. When we look, for example, at a human ancestor 1 million years ago, we find that they had 32 teeth. They had tremendously large faces. One of the things that will probably come up tonight is the issue of transitional fossils. They'll say to me, Dr. Hartman, if evolution is true, then we should see change. We should see evolutionary change over time, represented in the fossils that we have. I can show it to you. I've got it on overheads. I brought in some of the skulls. How many of you people in here have actually seen a real human skull before? Skull of an early hominid, an early human. I've got some to show you tonight. If you haven't ever seen them, I encourage you to look at them. One of the things we realize is that earlier humans had smaller brains and larger faces. Larger faces had plenty of room in there for all 32 teeth. Over time, one of the changes that's occurred in humans is that our brains have gotten larger. In fact, they're tremendously large today. Human beings have the largest brain to body weight ratio of any animal on the planet. Not the largest brain. I mean, a blue whale has a much larger brain than humans do. But blue whales